Good morning, everyone. My name is Noah Kelsch, and this is my circuits project. So first I'm going to take you through the design of my project. So it started off, not with this, not yet. It started off looking something like this, with a potentiometer and I was going to work in a switch here, and it was going to be a sort of dimmable 2 LED system with a capacitor that would provide a delayed response to the potentiometer, so that you can see this is still lit up a little bit. But early on in my testing process with my breadboard, I managed to completely destroy my potentiometer. It won't spin. I don't know exactly what happened. My hunch is that a relatively high voltage and current went across it and melted something together inside. And also, that same high voltage destroyed 2 of my LEDs, and it fried the end off of one of my battery packs. So, working with limited materials, I was able to come up with a different design that looks like this. So I sort of think about this as kind of like this being a solar panel providing energy, and this being a house with electrical appliances, that being the LED. And during the day, the solar panel could provide energy to the house, but also store it in a battery. And then at night, whenever there is no more sun, or just, the daytime in Pittsburgh, the battery would supply energy to the rest of the house for a limited amount of time that could be switched on and off using this switch here. So in a perfect world, this second switch would be a potentiometer that could allow dimming of this in some way, but unfortunately we do not live in a perfect world, and I do not live in a world where I own a potentiometer. Okay, this is the analysis section of my presentation. I cannot go into slideshow mode because Panopto will not record it. So I kind of made this into a sequential stepping problem where for t is negative infinity to 0, V, which is the voltage across the capacitor, is equal to 0. So then for t from 0 to 5, we close both switch 1 and switch 2. A KCL equation at A, and these will all appear sequentially in the slideshow, but they're just here now. KCL at A will give us VSC minus VA over 5 equals VA over 10 plus 0.1 dVA over dt. Rearrange that to get that into a differential equation form. Your homogeneous form is VA of H equals A times e to the negative 2t over 0.5. Your particular solution is VSC over 2, and your final solution for that will be VA of t is equal to VSC over 2 times e to the negative 2t over 0.5 plus VSC over 2. So then for t equals 5 to infinity, we open switch 1, so our circuit will look like this. And our governing equation is that V capacitor of t equals Vf plus V naught minus Vf all times e to the negative t over tau. Tau is equal to Rc, which conveniently gives us 1. Vf trends to 0 as t goes to infinity, and V naught is equal to Va of 5. So our equation is Vc equals Va of 5 times e to the negative t. Thank you. This is the prototype and validation portion of the video, and I realize that it's already too long, so let's get into it. So as you can see, the voltage across the entirety of my circuit is around 2.9, 2.8. This is because I connected 2 batteries in series. Don't connect 3 because that's whenever things start smoking. You can also see that the voltage across my capacitor is not 0 like it says in the problem. That's because I had a failed take earlier. So switch 2 is already flipped. If we flip switch 1, we see that the light turns on, the capacitor begins to charge. The voltage across the capacitor should be rising. you can see that it's already risen to about the voltage of the battery. And then if we turn this off, then you can see the light remains on, and I won't keep you here too long, but just trust me, it takes a while, but it will continue to dim, just like the degenerative equation in the second part of the analysis said so. Thank you.